Hello, good morning, good afternoon, and good evening to everybody. Welcome to our webinar, 4 Key Considerations for Your Big Data Analytics Strategy, which is co-presented by Arcadia Data and EMA. My name is Paul Lashmet. I'll be your moderator today. And more and more companies are turning to big data analytics to fulfill their need for information, but some of their tools are simply not sophisticated enough to scale effectively. So today we have Steve Woolidge, VP Marketing at Arcadia Data, and John Myers, Managing Research Director at EMA, who will provide us with 4 key considerations that we should all think about. And John, Steve, thanks for joining us today. Just want to let you know we have a pretty good audience here. It's international in nature. We got pretty much all the continents, including Australia. And the audience includes data architects, project managers, and even marketing directors. So I think we're going to have a pretty good conversation here. So these are the 4 key the sections that we'll be going through. Big data analytics have evolved. The discovery, looking at real time, where self-service is important. We'll give some real world examples, and of course, as I said, we will do the question and answers. And consideration number 1, so big data analytics have evolved. Hey, John, can you start us off with that?
Yeah, and then Paul, thank you for a great introduction. It's great to be here with you and the team and presenting with Steve. And, you know, I think one of the things that is really driving the evolution of big data analytics is something that we at EMA call data-driven cultures, data-driven strategies are all part of being a data-driven organization. So in the past, we had organizational structures that were based on looking at data as kind of a backward-looking, or if you will, the exhaust of their operations. So, you know, what was in the transaction log was, you know, the revenue for the month, and we're always kind of looking backwards. But we're seeing a lot of organizations that are starting to say, how do we take the data that is inherent in our organization already? If you kind of look at that data icon on the left-hand side, how do we analyze it? How do we discover inside, explore around in it, and how do we use it to help us become a better organization, whether that do cross-sell, upsell to our customers, whether that be improving business models, things of that nature. But really at this point, these organizations are saying, how do we take the data that we already have, or these new data sources that we see in the environments, and how do we leverage that? Here at EMA, we have a concept called the hybrid data ecosystem. And as part of that, we've looked at what are some of the applications that organizations that are really using as part of their big data environments. And they're really looking across a wide swath of different types of things. Sometimes we think of big data as being kind of the data science or the exploratory environment only, but it's really evolved since those early days of Hadoop. We now see organizations doing all the way from that exploration type of activity to operational analytics, trying to use it to address fraud, whether that be if you're looking at it from a credit card transaction or a telecommunications event type of process. How do we look at it in terms of operational processing? How do we make big data part of the core of what we're doing for our business? And then they're also doing analytics. And in terms of what they're doing, they're managing their operations, they're looking at customer experience, they're looking at marketing and sales, they're getting new insights into their customers and their products, which products are selling well, which customers are interacting with our applications, et cetera. And how do we look at the way that we can manage cost and risk associated with that? In those early days of big data analytics, you know, we had kind of the prototype data scientist, and the gentleman on screen is actually the guy who was CTO for Obama 2012 and 2008, and he's a great genius. He looks at a lot of great information, but he was a very technical resource. It was someone who really got into the numbers and the data, what was going on. And we're seeing an evolution of the data consumer associated with big data, and we're seeing that individual being more of a senior or advanced business analyst, someone who looks at the business reasons for what they're doing with the data and less of the technical aspects. And a lot of these folks are looking at things differently in the world, whereas we might have had our traditional data scientist as someone who could drop down to the command line, do a lot of their own analytics in terms of a script or something of that nature. These citizen data scientists, these advanced business analysts, are looking at things a lot differently, and the tools that support them need to be a lot different in the way that they take a look at things. Now, Steve, I know that you guys over at Arcadia look at this challenge the same way that we're seeing it at EMA.
Yeah, and what's interesting to me is I've been in the big data market for about 10 years, and 10 years ago we would talk about how data has changed, and it's instead of rows and columns, it's complex, multi-structured. There's more need for real-time information on that complexity, lots of different data sources. So we talk about data variety and velocity, the three big V's, if you will. And it was systems like Apache Hadoop, which really gave a lot more flexibility for people to deal with these multi-structured data sets in ways. And to your point, it's the data scientists or these really technical people that would go in there with, Python, MapReduce, different types of coding environments, Pig, and I don't even think Pig's around anymore, but Hive and these different things to be able to get information out of that. But really what has not changed is, until recently, BI tools. As you said, SQL is the lingua franca for analysts that want to go after data, but the BI tools that we have today are really relying on creating aggregates, pulling data out of those Hadoop clusters in many cases, or if you're trying to query Hadoop or cloud-based systems, a lot of times they haven't built in really good workload management things and such. So, the question has been, why haven't the BI tools really evolved to keep up and enable these business analysts to do what they want? And part of it's the architecture. They don't, BI that was built for data warehouses were not built to scale the same way distributed scale-out MPP systems work. They run on a single node environment, and that's fine if you've got a small number of users to go after big data, and it's fine if you've got lots of users on a small data set, but it doesn't do the combination of those two. And BI that's built for data warehouses weren't meant to interpret JSON structures or other semi-structured things that have metadata and schema sort of embedded in the data format itself. So then you've got to flatten out the data, put it into a relational format, really, that these BI tools can access, and that just slows things down. And then the other thing that I think is really interesting is the promise of Hadoop and big data was load and go, schema on read instead of schema on write, meaning we don't have to transform the data and get it normalized before somebody can access it, which in the data warehousing world, I've worked with customers that literally they would say that if they wanted to add a new dimension to the data warehouse, it would literally be 6 to 12 months worth of time to go through all the process to get it set up, and roughly $1 million of costs at a large healthcare company that I had worked with previously. So that agility that people need in the big data world can't operate in that way. So what we see is that people that have either a data warehouse or a data lake, if you're using a traditional BI tool, you have to go through this process where you land the data, you secure it, you're going to build some kind of a semantic layer or a model to be able to put business terms on that data. Then you'll need to move that into a BI server, or you could create optimizations within the data warehouse to speed up the performance, and then provide that security layer and performance modeling to the end user so that they can do ad hoc discovery and analysis. But like we were talking about, if those sets of questions that IT set up in the schema for an end user to access, if all the data wasn't there, that end user has to go back to IT and say, hey, I'd like to add this dimension in, and that's where that cost and that time comes. So when you get into the second iteration, the nth iteration of all the different questions somebody will want to do data discovery, it becomes a very arduous process. You have to keep going back and forth to IT. So what we're really trying to do is make sure that you don't have these issues of delays and repetitive nature, and this is just a long process and a lot of cost. So we want to shorten that within the data lake, and these new BI technologies that are native that run inside the lake provide a lot more flexibility. You can do the analytic discovery up front because they can interpret complex data on the fly. You don't have to do performance modeling until you decide you want to push those insights out to a broader audience in production. Also, there's only one security model. The native BI tools will just inherit the security that's based in the data platform. You're not moving data out to a separate BI server or into a data warehouse. So all the data that you need is in one system. So it just speeds up dramatically the iteration for discovery, but then also being able to deploy it out to a large number of users in a production mode. So that's really what's changing, I think, from the process perspective to enable those end users, which are much more business oriented, to your point, John.
Oh, I agree. And I think that one of the keys to this is being able to discover that detail. So a lot of data-driven organizations are able to go through that process, because a lot of times you don't know what you're trying to look at. You're trying to make that consideration. And you know, a lot of times when we're presented with information, it comes in this big mass of information. It's very hard to tease out the key components that go along with that particular aspect of visualization. And a lot of people, what they do is, because people are naturally a very visual, pattern looking group, to be able to bring that information out and to be able to take a look at it. Now, in the past, we've had situations where people have dumped data from, you know, whether it be a Hadoop environment, an EDW environment, whatever, and kind of gone with a desktop cowboy type of approach, where they're looking at and exploring data only on their desktop. But when you do that, you've got to get the cut of the data, as Steve pointed out. You've got to look at it. Now, after a while, it becomes isolated on a particular environment, and you really don't have the smoothness that you would like. You know, you may find an insight, but you may not have the data that the underlying supporting data that really makes that work out. So we're looking at organizations that are really trying to stay away from this type of desktop cowboy approach to their exploration. Now, you know, I've talked about how exploration is great for data-driven organizations in terms of what they're doing with exploration, what they're doing with analytics, how they're looking at their operations. Another area that we're seeing a lot of value in is the growing area of machine learning and artificial intelligence. Now, a lot of people think that this kind of just occurs. Hey, I'm now machine learning. But a lot of times you've got to get that data so that you can look at it, do some exploration around it, understand the components that go with that. And after you've done those things, then you can really enable that machine learning process and that artificial intelligence techniques that allow you to scale this out. But being able to use discovery and exploration at that detail level is really where organizations are finding the value of doing this. And if they can smooth that process, it really makes things better.
Exactly, and there's a lot of excitement around machine learning and artificial intelligence, but if you can't make it usable to end users, you know, there is a lot of automation of things that'll happen. But in the case of cybersecurity, we've worked with companies that need to enable security analysts to be notified if there's a potential threat using AI and machine learning. And in this screenshot, we're showing a demo application we've built where machine learning is ranking essentially the potential threats of different endpoints or users in a network, and looking at the net flow data of all the log files through the system. This is an entire view of all the different systems within an organization, and being able to do visualization exploration then of, all right, I see that there's an issue here potentially with this endpoint. Looking over on the right at the network graph, what are the other machines that endpoint's connected to? Who are the users associated with that might be involved in this scam or something that's happening? And then be able to drill to as much detail as necessary right within one system. You know, we'll call it swivel chair analytics. If you have to swivel from one application to another to try and do this types of threat hunting within cybersecurity, it takes a lot longer to address the problem. And you know, we've all seen the news where banks and retailers, et cetera, are getting hacked. So the more visibility we can provide across all the big data to the security analyst that may not be, you know, a data scientist, but they can understand network performance and net flow and all those things is really, really important. So that's the kind of things that you know, are really possible when you've got access to all the data on a system that allows end users to self-serve. So the thing I would say is that there's different types of architectures that are out there, and we really need to be able to scale to support, petabytes of information for these types of scenarios. One example is when you've got a data warehouse BI tool, like there's nothing wrong with that. You can still pull data out, you put it in the server, but it's going to, again, be aggregate summaries. You're not going to be able to drill to detail as quickly as you need to. In many cases, you might have to call up the data scientist to go figure out what's happening down at the log file level. Not to mention you're shipping data around. You have to do different types of modeling within the BI server, which is different from the data lake. You got to keep those in sync as well as the security. So that can be a hurdle. There's been a new generation of big data BI middleware, essentially, that allows you to do cubing on the data lake cluster. And what happens is it's kind of like the traditional cubes that we saw 15, 20 years ago, where you have to model the cube in advance. You figure out what are the dimensions somebody's going to want to analyze. You put that on an edge node in the cluster, but that's only refreshed, once every 24 hours typically. So it's not a real-time view. And again, if there's some detail that someone wants, it's not going to be within that cube view. So then they've got to go down through another tool to get down into the detail. And important is a lot of the data locality and the information about how to speed up queries is stored down at the data file level. So or at the file system level. So if you're only passing SQL queries back and forth with the BI tool to these edge nodes, they're just losing a lot of the understanding of how that data is stored, the different filters and semantic information that's out there. So again, native BI technologies are meant to be a fully distributed BI server that runs directly in the data lake. So whether that's HDFS or on an object store in a cloud environment, the data locality, the understanding of where data is placed so that you can optimize query performance and push down that semantic model, that semantic layer as far down into the distributed cluster as possible, really speeds up the performance and the intelligence about how to do that. And what also happens then is, yes, there are aggregates and logical views that are created or physical views of the data that will speed up and allow you to have hundreds of security analysts being able to monitor the network, let's say. But it's done iteratively, and it's based on the actual usage of what tables people are accessing, what queries they're running, and then machine learning is essentially recommending a way to structure that data so that the queries can be sped up over time back to the administrator. The best part is there's no data movement. Security is only applied once. You don't have to worry about people taking data out of the cluster onto a separate BI server on their desktop or on their desktop, which gets into a data governance issue. So this allows IT to keep it really clean and allows the end users to access, analyze, and share information. We call this lossless, in that you're not losing any of the high fidelity, high definition insight because it's all done natively within the data platform itself.
And Steve, I think one of the things you raised here with the native BI within a data lake architecture example is not just from a data governance, if you will, from a management of the data perspective, but now we're starting to see privacy and regulatory compliance become a whole lot more important to organizations, particularly with, I guess the current boogeyman out there is GDPR and its implementation timeframe in later this year. But being able to minimize the hops or the replications of the data that you're talking about, you're talking quite nicely about the high definition analytics that goes along with it. You also have that sense of understanding inventory and management of that data that allows you to answer questions, if you will, about PII compliance, PCI compliance, GDPR inquiries, things of that nature, where in these other architectures, it gets a little dicey about when we have different pieces in different places.
Yeah, that's a great point. And it's only going to get more and more stringent, and that need for data stewards and data governance is going to just continue to increase.
Yeah, those are really insightful and important points also. Hey, let's get to consideration number 3. So real time is a real thing. John, can you start with that?
Oh yeah, most certainly. You know, one of the things that we're seeing at EMA is the increased use of
I think we're going backwards here.
Pardon me for that. Analysts shouldn't be trusted with
Yeah,
the
there we
tariffs.
go. Looks good.
One of the things we're seeing at EMA is the really growing area around streaming data and streaming data integration points and things of that nature. So we've done multiple end user studies. In one, we saw 82% of organizations are looking at streaming technologies and streaming applications, and in another one we saw 72%. So there's a lot of organizations that are getting into how can we look at the real-time data that comes from our organization. Again, those new data sets that data-driven organizations are focused on. Now, some of them are those traditional types of IoT instances. So, connected vehicle, data coming off of wellheads out in an environment. How do we manage better our renewable energy contributors to our electrical grids, et cetera? But we're also seeing it in terms of real-time applications. How are we looking at ordering, fulfillment, and payment to be able to better understand how these things are going? This gives us that ability to, as these data-driven organizations are like, can we start to project the types of sales that we are going to see based on the people who are browsing, the types of products that they're browsing? What are some of the components that go along well with that? Are we seeing order and fulfillment and payment all within a particular time frame? If so, what are the products that make that happen? If we see lags, what are the products or customers that are like that as well? And taking that same type of mentality down to the mobile or online path analysis. So being able to understand, not just from that transaction level, which is, the shopping cart, things of that nature on the backside, which would be very backward looking, but what path are our customers taking to get to either a purchase or an abandonment, or what are some of the things that they're doing? Are we seeing customers that are using us as a showcase to look at things that they might buy in other locations? How are they using our mobile applications and things of that nature? But in these areas, we're seeing organizations take on that real-time streaming type of approach, and it can't, a lot of those things are not available if we take that approach that Steve was talking about. If we have to stop and replicate or move data in particular places, because when we look at the new business models or the new product development that goes into the business scenarios associated with streaming in real time, we don't have time to make those particular stops. In terms of process and operational productivity, you oftentimes will find organizations that are looking at how do we improve the performance of our manufacturing floor, or how do we improve the performance of our warehousing or our inventory processes. And while there is some wiggle room in there, if we don't have a product, how do we get that information to our customers in a time frame that allows them to make the most of that, whether we can offer them a different product, set their expectation that the product they'll be getting will be later on. And then if we can start to bring that into our supply chain management, to be able to say, how do we understand where all of the inputs and outputs of what we're trying to do are sitting within our supply chain, and be able to manage those things cross purposes. Now, again, some of these can have a little bit of wiggle in it, but for the most part, the business analysts and the business models that are looking at these new types of things need to be able to rely on that real-time, scalable types of activities so that they can identify a new business model as it's taking place. So imagine, if you will, we had a major sporting event and somebody wore just the right shirt, and everybody goes, hey, I want to have that shirt, or the right type of glasses. Now, if you're a business analyst, you can go, hey, can we support that? Can we set that up? Yes, we do. We can get it. We can identify it. And now they can execute on that. Whereas before, when we had friction in there, or we had that lower fidelity of the analytics or exploration process, we would run into issues that went along with that. Now, to say that we've got this the stuff going with streaming is a perfect panacea or a silver bullet, if you will. we actually have gotten some obstacles to what organizations are trying to do. One, the quality and the reliability of the data that goes back to that multiple hops or day later types of approaches for big data analytics. You know, do we have the right data, and is it where we need it to be? Can we get that connectivity, real-time connectivity to those data sources so that we can feel confident that as we build something out, we'll be able to get the right information to the right people? I think the only thing worse than not making a recommendation at the end of a sale for a cross-sell, upsell type of thing, if I'm an online retailer or I'm trying to create that great customer experience, is to make the wrong one, to not understand what a customer is doing right then and there, or what they have been doing over time, and say, hey, how can we help these folks do that? You also see that a lot in terms of customer care. How do we understand if a customer is having an issue with one part of our organization, now they want to be on customer care, how do we get that? And then the other issue is the inability to ingest or to store that data as we're moving forward, because as the streaming data starts to build up, you know, I think everybody kind of imagines that all of our connected fleet vehicles will be automatically or automagically enabled with streaming data. It's going to build over time, but once we get to some of those critical links, we're going to have a whole lot more data coming into the systems than our organizations are really able to handle. Now, Steve, I know that you guys have seen some great ways to handle that in terms of how the Acadia platform works.
Yeah, to your point on connected vehicles, right? You want to be able to see what's happening in real time within your fleet, and if there's, you know, a driver that's stalled out somewhere, or there's an issue with a machine, be alerted to that in real time so the analyst can see what's happening, but then also be able to look down into the correlation of, you know, is there a part that's failing based on driving behavior over time and that sort of thing. So what we see is, you know, people call it a Lambda architecture, but you have sort of a path for streaming data. You need to be able to visualize that. Then you also want to land and store that data over time so you have that historical context. And, you know, if you can provide both the real time and the historical in one interface for an analyst, it just helps reduce that friction like you talked about. And Kafka is certainly one of the things that we're seeing more and more customers adopt for the streaming layer. There's also Spark Streaming and Flink and all these other streaming technologies out there, but it's just a pretty fascinating world. I mean, we live in a real-time on-demand world between Twitter, Snapchat, and everything else. People expect to be able to sense, respond, interact with data in real time, and the enterprise needs to be the same way. It just happens to be a lot larger data volume. So that's what we need to be able to deliver to our clients for sure. And part of that, sorry, slide movement here. The other part of that is complex data, as we mentioned earlier, and you had the visual of it. It's hard for humans to interpret the stuff you see on the left. And you know, this would be a JSON file where you've got nested structures, and traditionally you'd have to flatten this out, put it into some tables, and then serve it up through a data warehouse-based BI tool. But really, a native approach allows you to interpret that, build the structure on the fly, and visualize it directly on the data as it's landing in the cluster. So the alert might be coming in on the stream and you're picking that up, but it's also being written and queryable instantaneously, essentially, as it's written to disk in the system. So it just really streamlines the ability to look at that information as well.
Yeah, and Steve, I think one of the things that you raise is a good one. You know, you show the structure on the left-hand side there, and there are a lot of times we're seeing with streaming data sources that they are still in that process of defining what the structure is going to be. So some organizations will say, hey, let's flatten our JSON so that it starts to look like a table. Now, that's one approach that can work, but if you have flexibility and variability in that JSON, you're going to run into issues where either you have data that doesn't match up with the flattened table structure, or you're going to start to lose data elements that go along with that. And I think that's one of the things that, particularly in these early stages for IoT, and particularly for the environment around mobile and application development, a lot of those guys, I wouldn't say they're going by the seat of their pants, but they don't have as robust configuration and change management as we probably would like to see in those environments. And they're changing their JSON, which is what it's designed to do, on the fly, and you need to be able to handle that as opposed to making a choice of, do we let it in and lose some of our fidelity? Do we keep it out? Having that flexibility really enables organizations to do what they're trying to do.
Yeah, and John, I think that's a great point with regard to usability and just understanding the data that you're working with. That takes us to self-service. John, you want to start off with that one too?
Yeah, no, as I've talked about, our big data consumers are coming in all shapes and sizes. So we've got the traditional data scientists, we've got our BI analysts, those folks that might be a little bit more focused on the technology side, but we're starting to see people that want to get and interact with this data in data-driven organizations that are coming from our external users, like customers or partners. We're looking at our line of business executives who want to say they want to get into and start taking a look at this data as it's being made available. Our operations teams, those frontline employees, really want to start getting their fingers in the data. But unfortunately, not all of these folks are looking for the same type of experience, but what they are all looking for is a self-service type of experience. So going back to Steve's point, removing that friction of how things work. They always want it now. I've never met a business analyst or a business executive who's comfortable with waiting for the data. And when we look at it in terms of a data-driven organization, those requirements continue to churn up. But how can we get people the information that they need and in a format that they can use quickly without having to get them all into these big environments? And the best example I like to use, and I don't know if you folks like to use it or not, but the U-scans that you see popping up at big box retailers, the home improvement store that I go to now uses them. My grocery store uses them. I hear a rumor we're soon to have an entire store that is nothing but self-checkout. But how do we enable that so that if I've got a small question or a small task that I need to do, how do we get them to be able to go out and get that working? As I pointed out, our data scientists and our advanced data analysts, they're going to like that exploration experience because they kind of know what they want to do. They are comfortable with the technology and things of that nature. But as we get out to more of a frontline employee or the edge of our data interactions, our partners and our customers aren't going to want that exploration experience. They're going to want to know, hey, this is the order that I have. Can I understand where it's going? If that's a partner, we can look at how there's the products they're selling through us, how are they being managed? Our operational teams, like our frontline employees, a great example of customer care. A lot of those folks don't necessarily want to or have the time in their job to go exploring around in data. What they're really looking for is to have the information about a customer pop up. Are they having a good or a bad experience with our organization? Are they a good customer, a neutral customer, or a bad customer? Sometimes I describe it as gold, silver, bronze, and lead. And how can I help them with the next step? And that's much more of an application, if you will, than it is an exploratory dashboard where you have to start to go and configure and do things like that. But what we're really looking for is an environment that allows us to merge these two things together and really meet the needs of what each of these data consumers is looking for.
Yeah, and to do that, you need to have that performance, the scale, the speed to support these types of applications. The cybersecurity example I gave earlier was one where it's pulling information from your security systems and linking back. There's ways you can click on those things and re-rank information that's coming in and sort of correct the machine learning model. So there's this human element feeding back to that. Connected car is another example, but it's having that distributed system that allows us to have that scale and performance to enable that and link. And the other thing is just huge numbers of users, right? So we've got customers that are supporting over 1,200 users. We've got one that wants to scale up to something like 100,000 users and really build a customer-facing application, analytics as a service. Neustar is one example where they've built marketing attribution and other types of analytical services that they provide back as a service to people. So within the system, we've got to figure out a way to support that high level of user concurrency, so IT doesn't have to go and configure, multiple environments. It could be one multi-tenant environment. So what we've got is a patent pending technology around what we call smart acceleration, where again we are monitoring the data usage and providing recommendations on analytical views that can help support 100 to 800x faster performance for the end users as they come in. It's minimal modeling. We're not building it in advance. Those views are being created based on machine learning recommendations from the system on what data needs to be aggregated, cached, and stored in a physical way, in a different way to speed up that type of a data-driven application for the business. And this is a benchmark from one of our end customers. They're a large telecommunications company that supports webinar types of events, I'll just say. And they have a customer support team that needs to understand and troubleshoot the network if there's an issue happening with someone's deployment of this telecommunications company product. They were using traditional legacy BI tools and wanted to access the data that was stored in Hadoop. They were using or looking at different SQL on Hadoop engines like Hive, Impala, and Spark. And that gave them the ability to do granular analysis, but not complex queries, not for 30 concurrent users, which was their requirement for the system. And with a distributed BI server or a native BI product, handling and providing those analytical views, then we could see queries coming back in a reasonable amount of time. Whereas once you got to 15 or 30 people on the system, a lot of these other technologies just could not bring the results that's back at all. They just wouldn't complete. So this is a view of how that performance starts to look.
Wow, it's pretty amazing seeing all that, how quickly that goes. Hey, how about we get into some real world examples?
Sure.
John?
I've got a couple more, so I'll just, I was talking about this telecommunications company. At Arcadia, we work with a lot of, smaller startup digital first types of companies. Newstar was one example of that. They were market share and they got acquired, building that self-service marketing attribution type of a application, software as a service to their end users. But we also have large CPG companies, online retailers that are using cybersecurity. Kaiser Permanente is a customer that, back to John's point around data governance, their issue was they didn't want to have to pull data out of the cluster and worry about PII information that was downloaded to somebody's desktop with a legacy BI tool. So being able to keep it all in one place was really, really important for them. If you double click on some of these different types of marketing applications that people are looking at, you talked about the path to purchase, and that is sort of the golden path, if you will, of what people are trying to understand, which is how are consumers interacting with the brand and figuring out whether they're going to purchase something or not. So, do we have the right audience with our marketing? Are we scoring and understanding those consumers? Are we measuring the impact? What stores are doing well from a sales and distribution perspective? So being able to allow the campaign manager, the product manager, whatever it is, to see which campaigns are running, how people are interacting with that, and do multivariate testing, those types of things to see for the digital dollars you're spending, what's the value of that in reaching our audience. And then you might have really good sales in, let's say, the state of New York, but when you double click down into the zip code, or I've been hearing about people looking at down at the parcel level. So by household, being able to track coupons, digital ads, and different things, and is that influencing down at the parcel level, not to mention zip code, et cetera, of intent to buy and things like that. Are we wasting our dollars, marketing to a certain part of the state or the county? Those are the types of questions now that end users can answer for themselves once they've got all the data in one place. So this is really interesting in terms of the types of analytics that can happen. And then if you look at it from an operations perspective, this is a really interesting example where a very large manufacturing company used to bring in consultants. They would pull data from a bunch of different places from their supply chain, the trucks, the products, which warehouses, pallets that are being shipped out, how they're stacking those pallets with different products, is their waste and what's shipping to the various locations. That was a 6 to 8 month project and would cost somewhere in the neighborhood of $100,000 to do that every 6 or 8 months to look for efficiencies in the supply chain. But with all the granular data in one place, now they're integrating financial data together with physical flow data, not just for, let's say, a truckload of a product, but down at the pallet level. And now that you have RFIDs, it can be down at the individual, package level to optimize the pallet splits and what gets shipped where. And this Sankey diagram you see on the screen here allows people to do essentially what-if analysis, to look at all the different paths that a product is taking at different distribution stop-off points to look if there's a better way to do it. And so it's highly interactive. This type of analysis done in traditional SQL is multi-pass SQL. It's really complex, takes a lot of time, but with more advanced analytics at a very large scale of data with a lot of granularity, you can extract a lot more value and efficiencies in the supply chain. So this has been really transformative, as this person said, for their business. So it's just amazing some of the things that customers are doing now.
Steve, if you go back to that Sankey diagram, one of the things I think a lot of organizations get great value out of it is it dispels some of their preconceived notions about what their processes look like. They may have thought about a golden path, goes, this is the way it's supposed to work. But all of a sudden they start to look at a diagram like this one, and in real time they go, how are orders coming in to the fulfillment component without actually being quoted or estimated at the beginning? And then they go, well, wait a minute, are we missing data? Is there something wrong with our process? And in some instances, they find real organizational change that they can make. But because they have this access to that level of granularity without having to, go cycles with IT, they're really able to get great insight out of this type of analysis and the other ones that you've been talking about.
Yeah, great example. And this is a little bit technical, but I think for the architects on the line, people that have invested in various Hadoop platforms, one thing that I would point out, which is really interesting about native BI, is that we can install with existing systems like Cloud Era Manager, Ambari. We inherit security and role-based access controls from projects like Apache Sentry and Ranger and those types of things. So from an administration perspective, you have a lot more confidence that you can deploy this to a large number of users, and you're not worrying about keeping security in sync and what the BI department's doing, which is different from your tool. It's all, or from your platform, it's all one system. So this has been a huge time to value and just lower, administration consideration for people that are deploying data lakes to a much broader audience now to get the value that has been promised in big data. And I think, big data and data lakes, you can say it's in the trough of disillusionment, but I think it's because we haven't had good ways to give that access to a lot of end users to build applications on these platforms and really make it a big data application platform. It really, this is kind of the last mile of being able to do this to the business people that understand the business and how it needs to happen, and to build customer facing applications. Just a much more easy way to do that. Agreed.
No, and I think whenever EMA does end user research around big data, streaming, things of that nature, the security questions are always like voting in Chicago. People vote early, they vote often. I can almost see them like double clicking on the yes, security is really important to me. Almost, I wish I could get an intensity button for how quickly and how often they're clicking on that. But no, you raise great issues here. And as we look at privacy and security and moving into different components around how do we manage that security, it's going to be important to be able to answer these questions, because if you can't, your CSO might just fold their arms and go, no, you can't do that, or you run great risks of violating the trust of your partners, customers, and suppliers. So no, I think those are all great points and ones that I think are fantastic. So as we kind of look at what the next steps are, or kind of wrapping things up, in the opinion here at EMA, data-driven organizations are capitalizing on big data analytics to fundamentally change their business models. Organizations that focus on rear-looking data are going to be quickly left behind. I think we're already seeing that, particularly in the online and brick-and-mortar retail space. And I think we're just going to continue to see that. And these approaches require new and different methods than our traditional, if you will, collect, refine, present, model, all those different components, and we have to remove a lot of the friction out of what those traditional approaches have been. Keep their best, if you will, patterns, you know, for quality, data access, et cetera, but how do we speed them up and develop new best practices? And again, part of those new things I think we're going to see are detail and speed of access are really going to be key when we look at the future of big data analytics. You know, those data-driven organizations, they won't, the business stakeholders will not sit still long enough to allow their architectures to catch up. They will either move along with the group, or those guys will find ways to find alternatives to make that happen. So, you know, that's where we see from EMA where big data analytics are going in the near future.
Yeah, and from our perspective, yeah, I've been in this industry, gosh, 18 years now, and I think the same way we saw data warehouses created as sort of a separate thing that's, you know, designed for analytics, you know, back in the 90s. I think with the data lake and big data systems, we're at this scale out world where, you know, the laws of physics for hardware just cannot keep up with the growth of data, and it's only getting worse with IoT. So everything needs to go to scale out distributed systems. So I think enterprises need to look at having two separate BI platforms, one standard for your data warehouse, which is designed perfectly for what that's good at. But for the data lakes and the scale out cloud types of environments, you really need to look at a scale out BI solution that can enable you to create these data applications and enable the thousands of users to really get the value out of these investments you've made in collecting all this information. So that's our perspective on what's happening in the market. It's pretty exciting times.
Yeah, and I think, Stephen, what, you know, working off of what John was speaking about, this concept that you just introduced makes a lot of sense. Hey, we've got a bunch of questions, and I think we have some time to go through it. Just so everybody online, they know, you can put questions through the panel on the right, and also through the Twitter feeds. But while we go through these questions, I just want to give you some resources here. And just note on the right hand, we have a new EMA white paper that's coming out, and you'll be able to link to it from here, and we'll send it out on your email. But one question we have so far is, how do companies make the change from traditional to data-driven?
Well, you know, one of the keys is to make it culturally. If your CEO is sitting there with his arms folded going, you know, I don't need a machine to tell me what I know about my customers, I know them. Either they don't have a very wide customer base, or soon they won't have a very wide customer base, because there are people out there that are making these changes. So one, there's a cultural component that goes along with that. And two, you got to have the systems that allow you to take the data that you are collecting and make use of it. So as we've talked about today, being able to have an underlying architecture that is flexible and, if you will, nimble enough to meet those changing requirements. Because, you know, I can guarantee you one thing: data-driven organizations don't like the concept of, please write all your requirements down in a requirement document for me, and in 6 to 12 months we'll be able to execute on it. What they want to see is an environment where they can stick their fingers in the data, kind of pull it apart, take a look at it, associate some other things with it, and really find those new insights, and then be able to apply those insights. So you know, how you go from traditional to data driven, one is cultural, one is technical, and when that rubber hits that road, you're off like a shot.
Yeah, thank you. And this next one really, I think, starts speaking to the idea of self-service, but, you know, really getting to the capabilities of analytics that we get. Are business analysts technical enough, and that's in quotes, technical enough to drive value from big data analytics platforms?
Well, you know, that raises a good question. I've never seen a business analyst go, please send me the customer data from Hadoop. They always ask questions like, may I see the customer data? May I see the product data? And the more that we can encapsulate from them, I think there was a slide that Steve had up where he had an example of a JSON format, which was very confusing. Now, if you know the data, you know it really well, you can start to get in there. But if we can turn that JSON format and encapsulate that complexity without losing Steve's concept of the fidelity, then they can start to look at, oh, let me look at the number of customer events that we have. Let's look at the different products that are in these data sets. And at that point, they're very adept at being able to answer those questions, but simply dropping them in front of a JSON or some other type of text-based multi-structured environment, that's going to not necessarily confuse them, but it will throw up a barrier to them really jumping in. And if we can remove that friction, that removes that barrier, and now you've got business analysts who are going, this is how I can take a look at this data.
Yeah, and I can just imagine that just streamlines the process too. Hey, Steve, I'm going to give you a two-parter here, I think. How is AI and ML leveraged in big data analytics? How can BI tools leverage this?
Yeah, we talked about it a little bit in the webinar. I think to John's point on, are business analysts technical enough to handle big data analytics, let's say. I think what's cool about machine learning and AI is it's kind of like, I don't know, power brakes or parking assist, right? We want to provide intelligence to more casual users to enable them to do more things. So to me, AI is not just running models and automating the world where robots take over, but it's also assisting humans to make decisions more quickly. So in the cybersecurity example, it was monitoring all the stuff that's happening in the network and then bubbling things up for that end, for the security analyst to look at something that's potentially threatening, but then do some human analysis to interpret things that machines aren't quite there yet on. So that's our perspective on how AI and machine learning can help analysts.
Great, and a lot of people talk, obviously the cloud, right? And how does the cloud factor in with big data analytics? And specifically, can Arcadia Data support that?
Yeah, the second part is we have a number of customers that have deployed systems in the cloud. People are, not many people are cloud native, let's say, unless they build their business on, let's say, Amazon S3 to start, and we have companies like that. Neustar is one example where it's all cloud-based software as a service, which you'd expect. But most large enterprises are hybrid environments where they'll have some data in the cloud, some data on-prem, so we can work across both those environments. And certainly more and more people are moving to the cloud, and it's just they're working out, do we do a lift and shift and move our environment there, or are we going to re-architect things? It's primarily a cost-based thing that people look at initially. They don't want to have to manage a data center, but that's not always the right fit for certain industries, and you get into data governance and everything else. But I think over time, more and more people will be moving to the cloud. So we've architected our software to support that for sure.
Excellent, excellent. And I think we have time for one more. Yeah, so we got a lot of questions, so I'm going to try to get through these. Hey, John, can you give specific examples of how frontline employees can use self-service apps in data-driven organizations?
Yeah, no, I got a great example. Did a case study recently around an organization that does not a big group, but a smaller organization that ships out candy, snacks, etc., things that you might find in the break room of your average company. And what they did was they set up information about how first shift was doing against second shift and how they were meeting SLAs and things of that nature. Now, you could do that in an exploratory dashboard, but because they made it an app and they just presented it to their teams, those guys were now informed and saying, hey, second shift hit their numbers, we're going to go and try to hit our numbers, and not in a competitive cutthroat type of thing, but that friendly, if you will, competition that you see a lot of times between shifts or between offices and things of that nature. And it was very simple. It was about how are we meeting our customers' needs? How are we meeting our SLAs, which are all part of the way the organization is working, but presenting it in an app that was clean and clear, and those teams got more productive because they knew what the levers were happening, and people were presenting with information. I mean, I don't want to call it really, really old school, but what gets monitored gets managed, and when you present it to your teams, they want to get better, and if they know that something does that, it helps the organization.
Okay. Well, we're coming up to the top of the hour, and you know, I thought this was a great webinar. Thank you, John and Steve, for giving us your insight. And you know, as you see that, you know, as more people are turning to big data analytics as a standard now, you know, really understanding the ecosystem and what kind of tools you need to handle it becomes much more important. So I want to thank everybody for joining us. We didn't get to all the questions, but thank you very much. We'll get back to you, and you know, keep your eye out for this this new info brief that EMA is putting out, and it's going to be really interesting. So thank you, everybody, and good evening.